that I'm a geology graduate from the University of Limpopo. So in my honors here, I selected a hydrology project. So the project was titled Hydrogeological Characterization of Groundwater Resources in the Fetakgomo Municipality. So what I'll be presenting today is some of the work that I did there in that project. Okay, so the contents I'll be sharing today includes the introduction, the geology, the aquifer types, surface water resources, the groundwater quality, and then I'll wrap up with the conclusion. Well, Fetakgomo Municipality is a rural municipality which is located approximately 90 kilometers southeast of the Polokwane town, and it covers an area of approximately 1,116 kilometers squared. Well, the area has a semi-arid climate with rainfall occurring mostly between March and October. So the annual average of the rainfall is 401 to 600 millimeters. So this is the location map of the area. So this map shows different villages in the municipality. So right at the bottom, this is the Limpopo province, where I just tried to show where the municipality is located relative to their province. Well, the study area has mountains, which are mostly orientated in the east-west direction across the municipality. So there are areas of high elevation, which are indicated on the map with a brown color, and then going down the color ramp, so we start to have areas of lower elevation up to where we have a purple color representing areas of low elevation. So in areas of high elevation, that's those areas have low groundwater availability because of high levels of rainfall runoff. So in low elevation areas, that's where we have more or high groundwater availability because of the water has enough time to penetrate the ground and recharge the groundwater. Geologically, the municipality is situated in the eastern limb of the bushveld complex. So most of the area is covered by the Rustenburg layered suite. And we also have the lower granite suite, which is represented by a red color here on the map. And then we also have the Pretoria group, which are crops in some parts of the south, in some parts in the south of the municipality, and also somewhere in the north of the municipality. We also have the Quaternary sediments represented with a yellow color on the map. So the aquifer types which occur in the study area includes the basement aquifer. So the basement aquifers are the dominating ones because most of the area is covered by the bushveld. The basement aquifers are the dominating ones because the area is covered mostly by crystalline rocks or hard rocks of the bushveld complex. So this rocks has mineral crystals which are interlocked with each other such that water cannot move through them. So they have low porosity and permeability. So aquifer development in these types of rocks depend on the availability of fractures, dikes, zones of weathering, as well as contacts. Well, we also have the intergranular aquifers, which can occur in areas where there is rocks of the Pretoria group, and also where there is the Quaternary sediments. Intergranular aquifers are aquifers in which the groundwater can move through the pore spaces of the rocks. In such rocks includes the sandstones, which have high porosity and permeability. So intergranular aquifers are the most reliable in terms of water supply because of their porosity and permeability, unlike basement aquifers, which depend on the availability of fractures and dikes, which are not usually consistent in an area. Well, in terms of surface water resources in the study area, We have 4 seasonal rivers, which flows into the Olifants River, found in the western boundary of the municipality. So these rivers are the main source of surface water supply, but groundwater is also used to supplement the shortages, especially in winter when there's no rainfall and most of the rivers are dry. So the water in the study area is used for mostly domestic, agricultural, and mining purposes. Well, the groundwater quality was assessed based on the Department of Water and Sanitation domestic water use guidelines, as well as the South African National Standards 241 for drinking water. So fluoride, nitrate, pH, TDS, and electrical conductivity are the most important in understanding the quality of the groundwater in the study area. So these physical parameters must be within acceptable limits in order, because if they exceed those limits which are prescribed by the Department of Water and Sanitation and the South African national standards, the water can have health-related problems, or it can cause damage to plumbing, or also it can cause corrosion of appliances. I'll start off with fluoride. So the fluoride standard limit is 1.5 milligrams per liter in groundwater, in water. So this is according to the Department of Water and Sanitation. So in the study area, if we have a look at the map here, we have area boreholes which are represented by a red color. So these boreholes are the ones which have the fluoride concentration which is greater than the prescribed amount. So they occur in areas where there is the lower granite soot. So this is because the granites have high concentration of fluoride containing minerals. So as the water flows through them, it dissolves those minerals and then increases the concentration of fluoride. So other areas of the fluoride concentration, which is within the right limits. So if the water has higher concentration, if it has the concentration of fluoride, which is above the recommended limits, it can result in dental problems such as teeth discoloration and dental fluorosis. So it is important that the water should be tested before it can be used in order to avoid this kind of health complications. Coming on to nitrate, so the nitrate standard limit for drinking water is 12 milligrams per liter, milliliter per gram. No, excuse me, is 12 milligrams per liter. So in the study area, most of the boreholes exceed this amount. So we only have few boreholes which are represented by this tiny brown color, which has a range of 0 to 12 milligrams per liter. So the other boreholes which are represented by green, yellow, and red color, all of them, they have the nitrate concentration which exceeds the prescribed limit. So consumption of water which exceeds 12 milligrams per liter can cause health-related problems, especially in infants. They can develop a condition which affects the blood and the ability of the blood to dissolve oxygen. So the nitrate concentration in water is affected by decomposition of plant and animals' debris, as well as animal and human excrement. So the groundwater, which has 0 to 6 milligrams per liter, will not cause any health-related problems, but we can still have health-related problems from 6 milligrams per liter in infants. The pH. So the pH of groundwater in the study area is mostly alkaline. And then in areas where the pH is around 8.5, the water can have a slightly bitter taste. So in the study area, the pH ranges from 7.5 to 8.5. But then there's this area which is represented by I mean, the boreholes have a pH of 8.4 to 8.5. So this area is closer to the mine. The mine, the Goni Platinum mine, which is located where I'm moving my pointer. So this mine was allowed to discharge approximately 1.9 million meter cubes of water into the Rapulu River. So I think that water which was released from the mine has affected the pH in this area. So that's why we see that most of the pH in this area is around 8.4 to 8.5. So pH of the groundwater in the study area will not cause any major health effects. Total dissolved solids. So total dissolved solids, TDS, is a measure of the amount dissolved in organic solids in water. So the more inorganic solids are dissolved, the carbonate, bicarbonate, chloride, sulfide, nitrate, sodium, potassium, calcium, and magnesium ions also increases in the water. So this is because of the dissolution of minerals which have these types of ions. So according to the South African national standards, the TDS in drinking water should be less than 1,200 milligrams per liter. So in the study area, the TDS is okay. We have the lowest range of TDS going from 21 to 96 milligrams per liter, and the highest range going from 621 to 696 milligrams per liter. So the groundwater in the study area can also be characterized as fresh water because it has the pH, the TDS of less than 1,000 milligrams per liter. The electrical conductivity is the measure of the ability of water to conduct electrical current. So the electrical current is also directly proportional to the TDS. So in most cases, the electrical conductivity is measured instead of TDS, or is measured to estimate the TDS because it's more easier to measure the electrical conductivity as compared to the TDS. So the electrical conductivity is affected by the concentration of the ions which are indicated on the previous slides, such as magnesium, calcium, nitrate, carbonates, and others. So in the study, the electrical conductivity standard limits for drinking water is 170 millisieverts per meter. This is according to the South African national standards. So the water which has this electrical conductivity is expected to have a salty taste, and it might also cause corrosion to plumbing and appliances, but it will not cause health-related problems. So in the study area, we have bowls which exceed this amount. These are the bowls which are represented by a red color and also a yellow color. Hydrochemical facies. So hydrochemical facies refers to distinct zone of groundwater that can be described as having cation and anion concentration within definite limits. So in the study area, 3 quaternary catchments were selected. So for each of the quaternary catchment, a paper diagram was developed to determine the groundwater types in those quaternary catchments. So the quaternary catchments are B52J, B52E, as well as B52B. I'll start off with the B52B quaternary catchment, which has the mixed water type, as well as the sodium chloride water type. So the mixed water type forms due to the mixing of different water types, calcium, magnesium bicarbonate, the sodium chloride, and the calcium chloride water type. So when they mix together, they form the mixed water type, which is indicated here on the paper diagram in a red circle. And then we also have the sodium chloride water type, which forms due to high concentration of sodium and chloride ions in the water. So the elevation can be related to high levels of evaporation in the study area. And this also indicates that some of the boreholes intersected deep confined aquifers where there is long-term extensive rock-water interaction. So the B52 Quaternary catchment has the calcium magnesium bicarbonate water type, as well as the mixed water type. But the mixed water type, as I explained on the previous slide, that it forms due to mixing of different water types. But then the calcium magnesium bicarbonate water type, it forms due to the interaction of the water with the mafic rocks, which leaches off the calcium and the magnesium ions. And then the bicarbonate is sourced from the dissolution of organic carbon dioxide or atmospheric carbon dioxide. So the water which has this water type is associated with unconfined aquifers, which have been recently recharged by rainwater. The B52J Quaternary catchment. So this Quaternary catchment has a calcium magnesium bicarbonate water type. So as I indicated that this water type forms due to the interaction of the water with mafic rocks, which are a source of this calcium and magnesium, and then the bicarbonate results from the dissolution of atmospheric carbon dioxide or organic carbon dioxide. Just to conclude, the water in the study area, the groundwater is generally good and suitable for domestic use as prescribed by the Department of Water and Sanitation guidelines for domestic water use and the South African National Standards 241 for drinking water. But some boreholes do require treatment, especially those which have the fluoride concentration and the nitrate concentration which exceeds the standard prescribed limits. So it is important that the groundwater is tested in order to avoid health-related complications and damage to plumbing or appliances. So the dominating water types in this study area were found to be the calcium, magnesium bicarbonate, the sodium chloride, and the mixed water type. So the calcium magnesium bicarbonate indicates that some boreholes intersected shallow unconfined aquifers, while those which have the sodium chloride water type intersected deep confined aquifers. This is the end of my presentation. Thank you very much for your time.
Thank you, Gift. Very interesting stuff. I'll open the floor to questions and comments. I'd like to start with one myself. You didn't say anything, or as far as I can remember, about borehole yields. Across the area in question, are borehole yields okay? Is there a tendency for a little bit too much pumping, or is there scope for more pumping? Is there any relationship between borehole yields in terms of liters per hour and the type of aquifer or chemistry of the water?
In terms of the borehole yield, I think that it's okay. The boreholes can supply a sustainable amount of groundwater. So yeah, I think that's okay. It's just that in my research, I didn't really go deep into checking whether the exact numbers of the borehole yields or how the boreholes react to pumping.
Okay, well, thank you. Are there other questions or comments? I'm not seeing any activity. Someone's trying, but I can't hear.
It's Kevin here. Are you able to hear me?
Barely, Kevin. What's your question?
I just wanted to comment on if GIFT will be able to further his studies on a master's level, because I think that if we can try to further it and expand the project, it would be a very good MSc project.
Okay, thank you for that. Are there any other comments or questions?
There is a comment in the chat by Kolani.
Okay, I haven't. Mining activities were mentioned. How has mining impacted the groundwater quality and quantity?
Okay, yeah, there's been some mining in the area, but then the quantity, I'm not really sure. But then in terms of the quality, the water which was pumped out of the mine has caused the pH in the area to be higher than what we would expect. So the pH is around 8.4 to 8.5. Of course, it doesn't really cause any environmental impact to the marine, to the aqua's life, because they can like adapt to it. But then the pH is not. It might cause the water to be salty than what you would usually have if the water wasn't, if the mine didn't really discharge some water into the rivers. Thank you.
So we've got no real problems with mines producing poor quality water and getting it into the groundwater system. I think that's what I'm hearing.
Sorry?
The mines are they're not a problem as far as groundwater is concerned.
Yeah, the thing is the mines, there's only one mine in the area, and now currently it's not mining. So the last time that they were allowed to discharge water into the rivers, it was in 2008. I think that they didn't allow them to renew that license, which allowed them to do so. So far, like there's no problem related to the mine activities in the area.
Okay, thank you for that. Any other questions or comments?
Good day, everyone. I might be getting a bit too technical, but back to the mining again. Do we know if the mine that is mentioned here had any inflow problems which required them to dewater? And if the mine is not operational at this stage, some of those groundwater levels would have increased by now, and it would have impacted the water quality. Do we have any information on that?
No, no, I don't have that information yet. So, but I think if I can check it up for you, and then I'll do email you, or I don't know, maybe drop you a link to if I do find that information.
Are there any more questions or queries? Anything new in the chat box? Okay, well, Gift, thank you very much. This looks like the kind of project that needs to be done in a lot of different rural areas in South Africa, and I don't have a feeling as to how much information is available, but it's something that's certainly important and certainly should be looked at. With that, I'd like to thank you very much for your presentation. We did have a little bit of a break in the middle of it, and we'll try to edit that out, and we'll get it onto the GSSA YouTube channel. So Gift, thank you very much. And with that, Nolene, unless you have any more comments, I'll end the meeting.
Thanks, Craig.
Okay, thank you, everybody. Have a good weekend.
Thank you.